Welcome to Chapter 7, Ionic Equilibria, Acids and Base. Relate pH and pOH to the ionic product of water Kw at 25 degrees Celsius. So we are going to learn how to relate pH and pOH with Kw. Now let's go back to what we have learned in Form 5. pH is a measure of the concentration of hydrogen ion or hydronium ion in a solution. So the formula is pH equals to negative log concentration of proton H+. pOH is a measure of the concentration of OH minus ions in the solution. So this pOH negative log OH minus or hydroxide ion. We know that if it's a neutral solution, the pH equals to 7. This means that the concentration of hydronium ion and hydroxide ion is the same. If it's acidic solution, pH is less than 7. Thus, the hydronium ion concentration is greater than hydroxide ion concentration. If it is a basic solution, the pH is greater than 7. The hydronium ion concentration is less than hydroxide ion. Ion product constant, Kw. One of the most important chemical properties of water is its ability to act as either a Bronsted-Lowry acid or Bronsted-Lowry base. Water ionizes to a small degree to form very small amounts of hydronium ion and hydroxide ion. So one will react as acid, one will react as base. Okay, now for ion product constant Kw, when the concentration of hydronium ion multiplied by concentration of hydroxide ion, we will get a constant that is 1 times 10 to the power of negative 14 at 25 degrees Celsius. Thus, if we put log pH plus pOH will be equals to 14. Okay, so pH equals to 14 minus pOH. So in pure water or neutral solution, remember that the hydrogen ion or hydronium ion concentration is equals to hydroxide ion. Thus, if we have neutral, then we will get 1 times 10 to the power of negative 7 molar. Thus, the pH of water, which is a neutral solution, is equals to 7 because of the log. Now, let's try one exercise. Calculate the H plus and OH minus concentration in solution with pH equals to 8.3. Okay, we know that pH plus pOH equals to 14. So if pH is 8.3, then we can find pOH. So pOH equals to we will get 5.7. Okay, now how to get H plus? pH equals to negative log concentration of hydrogen ion. So we will get 8.3 negative log H plus. So H plus will be equals to 5.01 times 10 to the power of negative 9 molar. Don't forget the unit. Okay, then next one we need to find concentration of hydroxide ion as well. So we can use POH equals to negative log OH minus. And just now we have find what is POH. So equals to negative. Okay, so it is equals to 5.7 equals to negative log OH minus. So concentration of OH minus hydroxide ion equals to 1.99 times 10 to the power of negative 6 molar. Okay, this is one way of doing it. Another way, you can use the ion product constant. That is, just now we have shown that Kw equals to H plus times OH minus, and it is a constant. That is 1 times 10 to the power of negative 14. Okay. So 1 times 10 to the power of negative 14. Okay, let's say we use H plus because we have started with H plus. Then OH minus. Then the concentration of OH minus is 1.99 times 10 to the power of negative 6 molar. So you can use either one. Okay, so always start with, if you have pH, you can find POH. And then if you want to find the concentration of H plus, use pH equals to negative log H plus. If you want to find the concentration of OH minus, you can use POH equals to negative log OH minus, or you can use KW equals to concentration of H plus multiplied by concentration of OH minus, where the constant value is equals to 1 times 10 to the power of negative 4. So that's all for this part. KW.